Welcome back, my dear students, into the new video about the mapping and functions. That's the talk of the previous video. You'll be able to remember that's what we discussed. We are talking about the mappings. We defined what mappings are, and we had some kind of examples that guided us to the meaning of the mappings. Right? We had also to look at the types of mappings and examples attached, things like that. Now, our business in this video of the today's meeting is simple. We would like to discuss few things and we do our with it. Today, that's in the video, we are there to discuss something about the domain and range. Right, in the mapping and functions, we need to know what the domain is and range is. Right, more importantly here, you just have to understand what is it about this. Of course, the two, talk of the domain and range, are describing two sets that are involved in the mappings as such. So what is a set of a domain? What is a set of a range in mappings and functions? So to define what domain and the set of a range are, I'll use this example here where we need to work together, and thereafter we're going to have a draw what is, that's the talk of the arrow diagram. Then out of that, I'll be in the position to define what set of a domain is and what set of a range is. Right, so let us look at this example here. We are given set P, which is defined by 2, 3, 4, and 5. Those are the members. P is given as a set which is defined by the members as follows: 2, 3, 4, then 5. Right, they say these members are mapped onto another set Q. Set Q, right? So it means set Q has got also a list of members that are mapped by the members in P. Right, so the members in Q are defined by a relation, which is the operation described as the multiply by 5. Talking of the members in set P, we multiply by 5, we'll have a list of the members in Q. So just like you say, members in P and Q are related by this operation, multiplied by 5, right? Then there we'll have a link between the members in P and Q. So let us now find the members in Q which are defined in this case in the two sets. Right, so to get the members of Q, what we are going to do here is just a matter of considering the relation, which is the operation, talk of multiply by 5. So if I'm going to have the list here, I'll first of all consider a member that is going to be mapped by P, which is a 2, a member that is going to be mapped by 2 inside P. So since here we're talking of the operation is multiplied by 5, it means 2 is going to be mapped to 2 multiplied by 5, and the member of which is 10. And the member that is going to be mapped with a 3, it will be 3 product 5, and this gives us 15. And the member that is going to be mapped to 4, it will be a 4 multiplied by 5, which gives us 20. And then if we are to find a member that is going to be mapped with a 5, we consider a 5 itself multiplied by 5. So what we have here is 5 times 5 give us 25. Right, so what I have here are members described as 10, 15, 20, and 25. Right, so these are the list of members which are found in set Q. So if we are to have two sets here, it means we have got set P, 2, 3, 4, 5, and that of the set Q, we'll have that's a Q, P equal to 10, we talk of what, that's a 15, than 20, 25, like this, right? So at hand, we have got set P and set Q defined by these members. So now if we are there to draw the arrow diagram that is illustrating the mappings of set P and Q, just talking of the relationship that exists between P and Q, our diagram then will look something like this, right? It means we have got an arrow diagram that you can use maybe some type of what shape. And here, this is also the figure representing another set. So here we'll have a figure which is represented by this design. And this is containing members of set P. And this one contains members of set Q. Right, so in P, we have got a list here described by 2, 3, 4, and 5. So now if we consider set Q, we have members like 10, 15, 20, and 25. Right, so by the operation of multiplied by 5, considering all members in P multiplied by 5, we came up with a 10, which rings a 2 in this manner, and that is described by that arrow. The same follows with the 3, has to be mapped to 15 by that arrow, and then 4 maps to 20, and also 5 maps to 25. So this is all what we have here. So if you look at what is defined in this example here, we're really going to consider that the set P and set Q are represented by this diagram here. So this is the mapping. Right. Now remember what we're doing here. We would like to define what set of the domain is and the set of a range is. So by this example and what we have done here, you're going to realize that we have got 2 sets that we have obtained. One is the set of a P, another set of a Q. So if you look at this one here, this first set, we are doing operation on the members of the set P to obtain members in the set Q. So it is more like when you look at Q, in this case, we can describe Q as just like an image of P. Right. So here we can consider Q as the image of that is set P that is here. So now if we are there now to talk of what the set of domain is and set of a range is, the 2 sets are described by the 2 diagram that we have in the arrow diagram here. So this set P, which in this case is regarded just like as your object, is the one that is defined as set of a domain. So members in P, we have got 2, 3, 4, 5. These members here are all members of a particular set that we call it the set of a domain. So when you look at this one, this is a domain. Right. But now the operation was carried out on these members to obtain this list of members, which I describe these members as in the set of the image. So such members, they form a set that is described as set of range. So if you talk of the range is just like the image of the previously, of one of the set. You can call this one just like an object, this one as image when it comes to our discussion about the transformation. So we talk of this one as a range, this is a domain. Right, so now by this, you'll be in the position to every time follow what it is about the domain and range. So this is the best way how we can define set of a domain and set of a range. Right, now having known what a domain is and also a range is, now let us shift to something else. And this new thing that we're going to discuss now is about the function. Right, remember our discussion is about mapping and functions. We have now seen and be able to understood what a mapping is with all these examples. We are looking at the domain and the range and all other previous examples we have had in the videos. Right, now let us now pay attention onto what we call as a function. What is a function? And after, we have to look at issues that are related to the function itself. Right, so I'll remove this chart here. We need to focus on something else. Right, but we not run away from such type of discussions. We're still with them. Right, so functions. Right, when we talk of a function, function is not a new thing at right. It is still an issue about the same one we're discussing about the mappings. Remember, we discussed several types of mappings. You can revisit the previous videos. You'll be able to note that we have got 4 types of mappings. Right, when now we talk of a function, function is one of the types of the mappings. Or talk of the relation. A function that talk of a relation or a mapping that is defined as a function, it is that type of function that maps exactly one member of, now we call it a domain, with exactly one member of a range. It's just like a one-on-to-one mapping. Right, so here, to define just a function in brief, first of all, for you to understand it very well, you can take it as a relation in which each member of the domain, that's the set of the domain, right, corresponds to only, right, one member of the range, right, which we have also defined as just like an image. Right, so this simply is just like an one onto one type of a relation. We have to see that, say, one member of a range is assigned exactly one member of a domain. Right, so such type of relations or mappings are defined as what? Functions. Right. So for us to understand better, we can regard a function then just like a machine that processes a particular product, which we call the input, and yields the what? The output. Right, look at this. If I talk of the product and output, because for this one to be obtained, at least we have to consider a certain process that has to be carried out, one-on-to-one mapping. You should be able to expect a certain operation that gives you only one value for a domain. So we can regard that type of operations as just like machines. Operations which are defined as functions, just like machines. Like, say, for example, I may have an example of a machine like, say, a maize mill. Let's consider this one as a maize mill. You'll be able to appreciate that, say, whatever output in this machine, talk of like a maize mill, I'll be able to have my maize grains maize grain has to be put into this maize mill, and what will happen is just like this maize mill is going to process this maize grain and be able to give you a product here. Like this product is just a flour that comes here. Now if we can compare what was put here, which is defined as input, product, you also going to yield what we call the what? Output. So what we have here is just like maize grains. The maize grain that is put here is processed out. Once it has been processed, what you get is the output that call it what? Flour. So now if you can look at the two types of product, find that they're not all the same, but somehow they're related. Because just like the flour that you get as an output here is coming from the same what? Maize grain. So it's just like there's a relationship between the flour and maize grain. But now if you look at the stuff, they're not all that exactly the same. Here we have the grains, but here we have got the flour, the product. You can see them. The particles of the grains are large, while the particles of flour are very tiny. So in this case, we do not expect at all that say whatever will come out of the maize meal should be something that is quite different from the what? Grain as such. Right. So it means that self-talk of the maize meal is going to produce exactly the stuff that is related to the what? The stuff that was regarded as just like an input. So just like an input is exactly the same as the output. Talk of the two are related. Right. There's no way that the maize grain is going to yield you a different stuff here that is quite different from the maize grain as such. Right. So the same is applied again in mathematics. We have got such type of situations that work exactly the same as what the maize meal is doing here. Like say for example, look at this situation. We may have some kind of expressions. So like say for example, if we are given some values of maybe talk of values of a particular set, like here I've got a set, for example, like set A, which is defined by members like 1, talk of a 3 and a 4. You'll be able to see that say what I have here and a particular expression, talk of an expression like x squared plus maybe 4. Right? Let's talk of 4x. Right? Where whatever we see here are members which are represented by x, to say considering 1 is the value of x, 3 is the value of x, 4 is the value of x. Right. So similarly, what I've been doing here about the maize meal, you can be able to regard that maize meal as like an expression here. So if I'm going to redraw this one, I'll have a situation which looks something like this. Look at this. It goes like this as a diagram. And what are you going to read out here? So your input here will be the values of set A, which are defined by x. So this is just like x1, this is x2, this is x3. So your machine in this one here it was maize meal, but here you have an expression defined by x squared plus 4x. So if I'm going to have my input like 1 to be processed in this operation, what I'll have is just like 1 is my input. Now when this one comes here, it means wherever there's the x, I'm going to substitute with what? For x. So if I do this substitution here, I have got 1 plus 4. And what I get here is a 5. Right. And again, if I look at that, it means they have got 1 corresponding to 5 in this manner. And now when I consider the 3, what I'll have here, it'll be like now a 3 has to be now going to be processed in this expression. So it'd be like the 3 is going to be processed here. So more like this one is going to process a 3 and yield a different product. I don't think this one is going to yield a 5 again. So what we have here, just like when I have a 3 processed in this expression, you call this one of the machine. You'll be able to obtain, that's a 9 plus 12, that gives what? That's a 21. Right. So here you have got a 3 that is just like mapped into 21. The same it follows with a 4. 4 coming here, what you have just like a 4, substituted there, you get 16, that is plus 16, which gives you what? 32. Right. So here what you have is just like 4 is processed out to yield what? As an output, that is 32. So look at that. The same here. Maize meal, maize grain, you process them to give you maize flour. And when you have got maybe talk of the rice regarded as an input. This machine, which is just a mill, it is going to process that talk of the rice and you do a product that is similar to rice itself. It doesn't going to give you a product that is quite different from the what we have area there. Right. So what we have here, just like whatever I regard as output, whatever come here, it'll be something that is related to that. Nothing else will come from that one. So this is just like 1 onto 1 operation. The two products are related in one way or another. Right. So that process here is what is also happening here. Here we have got a machine which is defined like is represented by an expression. So if you can look at the expression here, what it happens, any value of x here, what is going to be processed in this one is quite different. They're not the same. So here what we have here, it'd be like when we're going to represent the results by the arrow diagram, we'll have a situation of two sets. One set is the first one of the members of the x, and the other set is the members which we have just yielded up here. And by the first definition, the discussion that we had, you'll be able to describe that this is a set of domain that is the set of what? A range. So if you can look at that one, this is just like one-on-to-one mapping. There was no way that 1 can be mapped onto 21 by this one operation. And there's no way the 3 can be mapped onto 5 by this one operation. And there's no way a 4 can be mapped onto 21 by this one operation. So such expressions like this one here, this relation, x squared plus 4x, this one is defined as a function. A function is a relation. So a relation in this case, we talk of this machine here, is yielding that. So I think this is enough for you at least to really understand what a function is. So when we talk of a relation that gives the one-on-to-one mapping, we are talking of a situation like this one here. Right. So having understood what a function is, can we just try just to take note one situation here, a situation in which you might always be required to do, that is a presentation of the function. Right. So like here, we regard x squared as in an operation that has yielded the two, has yielded up the set of the range, and this is your domain. Like from what we have here, 1, 3, and then 4. This what we get is the 5. This what we get here is 21, and here we get 32. That's what we have here. So the relation that maps members of this set of the domain to set of the range. The relation here can be described by this expression here. So you can have here like x squared, then what? Plus 4x. Like previously, when we were talking about the mappings, we had our relation being defined here. Is a multiple of, is a further of. It means that one is giving up the connection between the two sets, set of the domain and set of the range. Right. So this one here is what is regarded as a function. So to represent that function, we use different types of notation. We can use f, by the way, it's a function. How to denote it? If this one is the function, expression that's giving you, that assigns you exactly one member of the range from the domain. Right. So how you are going to present this one? You are going to present like say f, and here you open the bracket and close with another bracket. So this is read as f of x, right, is equal to x squared plus 4x. To mean that there's a relation that is there going to process all values of what? X. So in this case, it means what we have here in the domain, all these ones are members of what? These are members of the domain which are defined as x. So this is just like the value of x, value of x, values of x. So just like when we write f of x here, it simply means we are there going to process the values of x. Right. So it means the expression also here, which is defined as the function, should also contain x. But now if here we have got an expression that say talk of maybe in t, like say t squared plus 4t. It means what we have here, it means all the values which are in the set of domain are defined by variable t. So it means your function will be read like f of a t is equal to, that's a talk of what? T squared plus what? 4t. So a t is just like or I talk of any variable that is the instead in the bracket here is defining particular members of the first set, which is the domain. Like such that if you are there to maybe to write that one in general, what we have here, it'd be like a domain and a range here. Whatever we have here, you may regard them as x1, x2, x3 as such. But what now we are going to obtain here in this other set, to make it simple, are all values which are coming from the operation which has affected the first set here, which is the domain. Right. So the members which have been affected after substituting these values here in this expression. So what we get from this one after substituting this one are these values here. So these ones we can also define them by a particular notation which can be regarded as a range. So take to breathe whatever you see here as a 5. This 5 is coming from the value of x, which is the 1, which in this case have been represented by x1. So here the 5 can be symbolized as the f of x, and that one will be like f of x1, while the 21 coming from the 3, that one can be presented as the f of x2. That's the operation that has happened on the second value of x. And also if talk of 32 in this case can be denoted by talk of f of x, which is in category 3. Right. So what we have here, we can just like say what we have in the set of the domain. We have members described by x throughout, but what we have in the set of a range are members which are described as f of x. In short, the f is just like guiding us to say there was an operation that was taking place on the first members here, which are defined by what? By x in this case. Right. So to give the notation of the operation that has carried out in this case from the members of the domain to give us the members of the range, we simply write in this case say f of t, if all these members are categorized as the values of t. So it goes something like this, and this one is read like f of t is equal to t squared plus 4t. To mean to say that there's the operation on the values of the set of the domain defined by t to get the members of the range. Like sometimes you can write this one as f of t is such that let's talk of there's so many notations that you can have. You can sometimes have it as say f. Anyway, let me just use a different letter, not only f throughout. Sometimes you can regard your function in t here. You can use a letter g. You can use a letter h. You can use a letter maybe n, whatever. As far as that letter is defining a particular function, right? Like in this case, whatever operation, whatever expression that is going to give you a specific value of a particular member of the domain. You can prefer to use f, like f of t is this one. You can prefer to use h, then here you write f of h is equal to t squared plus what? 4t. Think like that. So it's up to you to decide the denotation of a particular a particular function. Right, but what is there, you should always be able in the position to understand that say a function is just a relation like this one what we have with here, that always it has to assign only a specific value of a set of a domain. Right, so like here this domain is just assigned only a 5, this 3 member of a domain 3 assigned 21, and 4 is assigned 32. But if you don't have that type of situation, like say 3 is assigned several members there, then the operation of which is not defined as a function. Right, so that's it that we can understand about the function as such. Right, so let's just have one example in this case where we might be asked even to draw the arrow diagram to represent the relation as a function. Right, let us consider set of that's a talk of domain as having values like 2, 3, 4, and 5. The question that we might have at hand is just like, can you find the corresponding set of the range that is going to map the members of the domain? So here we may be asked to find the stock of the range. Right. Actually, we're looking at the list of the values that can map up the members in the domain. Right. Given that f over x is equal to x squared plus 3x minus 2. Right. So what we have here is like we are given a certain operation or set of variation, which is x squared plus 3x minus 2, right? Defined like f of x, means that there's a function in x, a relation that is going to operate all members of x, right? That's it. So now, if we are going to find that range in this case, what we do, it will be like similar to what we have obtained there, and we are going there again to notice that say that this operation really going to give a specific value that is going to map a specific value in the domain. Like if that is true, then really what we have with the operation, we are really going to conclude that this really is what is a function. So look at this here. So what we have here, you can have your arrow diagram well drawn like this one to say this is my first set, and take it as a set of the domain. Have members like 2, 3, 4, and 5. And here you have got what? Another set which is not yet known. But we understand whatever we have here will be the members of the what? Range. And the every representation of that, since here we have got a function of f of x is equal to x squared plus 3x minus 2, then every member that will be assigned by members of the domain. Like here, talk of a 2. What is going to be assigned to a 2? So here you'll always be talking of the f of x. And here 3 will have its own value of f of x, a member of the range. 4 will also have f of x, and also 5 will also have f of x. So you have got f of x1, f of x2, f of x3, f of x4. Right. So which means these values here are members of the range. Right. That defined as f of x, because whatever is here, it means that say, when you write f of x, it simply means a member that is going to come after operation has been carried out on a 2 as the first value of x. So this is our x1, this is x2, this is x3, this is x4. And when I write f of x2, I mean a member that will be yielded after an operation has carried out on the second value of x here. So that one is represented by f of x. So just like here when we talk of x of 2, x2, here it means that a corresponding member of the range should be f of x2 aside. So try to understand this denotation here to say what exactly does it mean. So f of x simply means a member of a range that is assigned to a particular member of a domain. Right. So here all members of the range are represented by f of x throughout. Right. So now what are we going to have for this f of x aside? Right. So it means as far as this one is the function, it means that is the ratio that is bridging the two sets, domain and range. So here it means we have got x squared plus 3x minus 2. Right. So to do this, what you do, you simply just have to substitute, and we're really going to really check that if this operation here is really a function or not. We'll see if the members here are just assigned a specific value here. So like for the first value for the 2 here, what you do here, you substitute here, you have got 2 squared, which gives you 4 plus 8 minus 2. So like a 4 plus 8 minus 2, so the answer you get there is 10. So it means 2 is mapped onto 10. And here for 3, you have got a 9. That one 9 plus 9 minus what? 2. What you get there is 16. So here you write 16. So it means f of x2 is 16. And that one, it gives you 16. Talk of the 16 that case, plus 12 minus 2, and this gives you 28 minus 2, that is 26. So remember there is 26. And finally here you have got, let's say 25. That 25 should be added with what? 15 minus 2, and what you get there is 38. Right. So consider f of, that's the 10, is f of x1, the f of x2, f of x3, f of x what? 4 by the previous presentation. Right. So you can see this maps only onto 10, 3 maps only to 16, 4 maps onto 26, 5 maps onto 38. Right. So it means this type of mapping is defined as what? As a function. There is 1-on-to-1 mapping. Right. So by this, let us first of all stop here. I have hope that we have understood the issues about the function. Definitely, what we are there, just look at a specific type of relation that is defined as a function. So 1-on-to-1 is the kind of relation that is defined as a function. Right. So in the next video, what we have are some of the just discussion about the question that we need at least to meet, we need to see and try to discuss, so that when we are preparing for exams, we'll be sure to say what type of questions do we expect in these discussions here. Right. Thank you very much for being together, and I hope that you're also going to link yourself by the link down here in the previous videos as such. Let's be together in the next video. Thank you.